In section 3, we're going to look at stem and leaf plots, which are another way to display data. So down here we have a coffee shop kept track of the daily number of beverages it sold throughout the month of July. The results are shown in the stem and leaf plot below. So what we have going on over here on the left-hand side, this is called stems. All right, and then on the right-hand side, we have the leaves. Now, here's the way we're going to set up stem and leaf. So you'll notice that the stems are all in order from lowest to highest, and that's how we're going to generally put those in there. Leaves are the same thing. We've got in each stem we have what are called leaves, and then within that band of leaves, the numbers are from lowest to highest. And again, we're always going to do it that way just because that's the way we do stem and leaf plots. Each of these points is going to represent a data point. So even if we have duplicates, we have to include as many as there are. So for instance, 5 and 0, 5 and 0, we got to show that twice. Now, the way we're going to set up a stem and a leaf plot is the leaf is always going to be one number. The stem can be anything else. It could be one number, two numbers, three numbers. It really depends. And you'll see these as we go further. But the leaves always have to be one number. It's one data point. You'll notice right here that the 4 is blank, and that's okay. We want to make sure that we put that there, because if we don't, then the stem and leaf plot can be a little bit misleading. It also helps if we have to go back later and add data. If we have that blank leaf and it's there all ready to go set up, it's much easier to work with. So what we also have in each stem and leaf plot is a key. And the key here tells us what this data means. So if we have a stem of 5 and a leaf of 2, that means that the coffee shop sold on that day 52 beverages. So we had 7 and 1, that would be 71 beverages for that day. Question 1 says the coffee shop closed early on the 4th of July. Which data point do you think represents this day? My first thought is we're looking for the lowest number because, again, the shop was open, but it didn't sell a whole lot because it closed early. So the lowest data point I see is right here when we have that 3 and 7. So we're going to say 37 because that is the lowest amount. For the month. Lowest amount sold for the month. For 2, the coffee shop makes a profit when it sells at least 65 beverages. Again, at least. So if we had a data point of 65, that counts as a profit. How many days during the month of July did the coffee shop make a profit? So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17 days that are 65 or greater based on our data and our key. The coffee shop is busiest on weekends, which are Saturdays and Sundays. There are 8 weekend days in July. What was the fewest number of beverages sold on a weekend day? So we're just assuming that none of the highest 8 values are going to be weekdays because they're busiest on the weekends. So what we're looking for then are the 8 highest days, and the lowest of those is going to be our lowest selling weekend day. So if we start here with our highest number is 91, and then we have another one, and I do this in a different color so we're not getting confused with all these dots here. So let's see, 91, 2, 3, 4, 5, 6, 7, 8. And you'll notice when I went backwards, I started here at 89, 88, and so on. So this looks like it's the lowest of the most populous, or the days we sold the most. So that would be 87 beverages. Number 4 says, what's the total number of beverages sold in the month of July? I'm going to save you the gory details of this, but essentially what we're going to do is we're going to take 37 plus 50 plus 50 plus 52 and so on, and repeat that until we've included all of our data points. The second stem and leaf plot, again, the leaves are all one digit, but you'll notice down here we got 10, 11, 12, 13, 14. Those are 2-digit numbers. So again, that leaf can have multiple digits. A random sample of 30 Lincoln Way teachers was asked how many miles their cars have been driven. The rounded values can be found in the stem and leaf plot below. Notice the key here. We're not talking about just 3 and 5 being 35 miles. Now it's 35,000 miles. That's why it's very important we understand what that key is telling us. Notice again we have blank areas. That 9, 12, and 13 are both incomplete. It's okay, because again, if we have more data, we can put that in there. What's the most number of miles driven by a Lincoln Way teacher who responded to the survey? We're looking for the highest data point. That's right here. Based on a key of 14 and an 8 would be 148,000 miles. Number 6, which of the following represents the most common mileage for a Lincoln Way teacher? So A, we have 40,000 to 49,999, so that's 2, 3, 4 of those. B, we have 50 to 59,999, 1, 2, 3, 4, 5, 6. So far, that's the winner, so A is out of the picture. C was the 60s. That's not going to work. There's only 3 of those. D is the 70s. There's only 4 of those. And then E is the 80s, and it looks like there are 4 of those, so that one would not work. So B is the one that has the most common mileage for a Lincoln Way teacher. So in other words, if we were to randomly select somebody, we would expect their data most likely would probably fit in that range. Number 7, explain why the stem of 9 has no numbers to the right of it. This is where we have to use that key exceptionally well. So if we had a 9 and a 0, we know that's 90,000 miles. Contrast that with a 10 and 0, which is 100,000 miles. So the reason there's no data in the stem of 9 was that no teacher surveyed has between 90,000 and 99,999 miles on their car. Again, without that key, we can't really answer that question. It's interpreting the context. And number 8, in the United States, the average miles driven per year is 15,000. So per year is 15,000. Based upon this data, how many teachers who respond to this survey have a car that is 3 years old? So it's 15,000 miles every year, and there's 3 years that we're looking for. So total, we're looking for anything greater than 45,000 miles. Tying it back to the stem and leaf plot, what we're looking for is anything that's above a stem of 4 and a leaf of 5. So if we take a look at the data, I see 1, 2, 3, 4, 5, 6, 7, 8. And you know what? It might be easier if we just count backwards and subtract. So we said we had 30 sampled. So we're looking for greater than 45,000. So these would not count. 1, 2, 3, 4, 5 of those don't count out of the 30 we surveyed. Oh, I'm sorry, 3 years old or less. So, okay, those are the ones that we're looking for. Looking for ones that are less than 45,000. So 1, 2, 3 of those surveyed. Helps if I read the question, right? All right, let's move on to the next activity, which is how to create the stem and leaf plot. So we're going to kind of run through this a little bit quickly, but it's kind of the same idea as before, but now we're actually putting the stuff in there. So the chart below shows the average lifespan for a variety of animals. Complete the stem and leaf plot below. Remember, leaves should be written in order from smallest to largest. So they've set up the stems for us, which is nice. What we're going to do then is look for anything that would fit in the 1. They already gave us the key also. 5, stem of 5 and a leaf of 6 is 56 years. So we have a stem of 1, that's anything in the tens. So I've got a 14, 14, 15, 15, 15, 18. I think that's all the ones. Yeah, it looks like it. All right, so we're going to set up our leaves, and I'm looking for the lowest of the tens. That's 14. I see it twice. So I've got a 4 and a 4. And I've got 3 5s and an 8. So that takes care of the ones. I do the same thing. I'm looking for now the 2s. 24, 28, Anything with a 2 is our leading digit, and a lot of these guys. All right, and I'm looking for my lowest number, which in this case would be 20. So there's a 20 there. And 2 more of those. I don't think we had any 21s. We do not, so now we're on to the 22s. And I see 1, 2, 3 22s. 24s, we've got 1. 25s, we've got 1, 2. Oh, I missed a 24. There we go. 25s, 2 of those. 27 and then 28 would wrap us up. So 27 and 28. That should take care of all those. Now we're on to the 30s. So the 30s we've got, let's see, just 1 it looks like. 35, the lion. So we'll put that on the stem of 3, giving us a leaf of 5. And moving on to the 40s. So we have 40 years old, 45, and 40. So 2 40s and a 45. And then I've got 2 50s, 56, and a 50. So a 0 for the first leaf and a 6 for the other. So then that should take care of all of our data. Now, since the average lifespan of a rabbit is 9 years, how would your stem and leaf plot change to include this? So 9 years would look like this, a 0 and a 9. So we would have to add a stem of 0 with a leaf of 9. Of the animals listed, most live within which of the following? 10 to 19 doesn't seem, we clearly know it's this one here. We took the longest time with that 20 to 29, so we know most of the animals fit in that range. And again, that's the idea of creating that stem and leaf plot and then interpreting it. So again, make sure that your stems are in order from least to greatest. If there's any missing data, make sure you have a blank stem. That's okay. Your leaves are also organized with 1 number for each data point, and you always have to have a key so that we know what this data is even talking about.